Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0222, indicates a TP throttle position sensor B-circuit low voltage issue in the 2016 to 2022 Honda Pilot. This code pertains to the throttle position sensor B-circuit, which plays a crucial role in determining the position of the throttle plate. The throttle plate controls the air intake into the engine, impacting engine performance and efficiency. In the Honda Pilot, the throttle position sensor is located on the throttle body, which is situated between the air intake and the engine. When the engine is running, the sensor sends voltage signals to the powertrain control module, PCM, to indicate the position of the throttle plate. If the voltage drops below a specified threshold, the PCM registers the fault, leading to the P0222 code being stored. Correct functioning of the TP sensors is vital for appropriate fuel-air mixture and engine power management. When diagnosed, technicians often refer to several indicators from the vehicle's onboard diagnostic system to assess the issue. The TP sensor B circuit is responsible for providing critical feedback to the powertrain control module, PCM, about the throttle plate's position, which directly influences engine management. The throttle position sensor, TPS, is mounted on the throttle body, an essential component located just upstream of the intake manifold. It converts the mechanical position of the throttle plate into a voltage signal that the PCM uses to adjust fuel delivery and ignition timing for optimal combustion. The TPS includes two sets of circuits, A and B, with sensor B being the focus in this error code. When the signal voltage is below the expected threshold of 0.3 volts, the PCM triggers the DTC. This low voltage condition can lead to poor engine performance, affecting acceleration and fuel efficiency. Understanding the role and location of the TPS is crucial for technicians to effectively diagnose issues related to this DTC. The causes of the DTC P0222 can vary, and proper diagnosis requires a methodical approach. A faulty throttle position sensor can produce incorrect voltage readings, resulting in the low voltage fault. Additionally, issues in wiring, like a short in the THL2 wire, can also lead to decreased voltage signals being transmitted to the PCM. This wiring connects the throttle body to the PCM, making it critical for accurate signal transmission. Another point of focus is the VCC5 wire, which supplies the necessary voltage to the throttle body circuit. If there is an open circuit in this wire, voltage flow may be interrupted, causing similar low reading issues. Identifying these components and their associated wiring is essential for resolving this DTC and ensuring proper engine performance. Thorough inspections should be conducted to eliminate all possible error sources systematically. When a P0222 code is present, several symptoms may manifest, affecting the vehicle's performance. One of the most noticeable symptoms is poor engine performance. This can include sluggish acceleration and an overall feeling of reduced power while driving. Drivers may also notice that the check engine light illuminates on the dashboard, indicating that there is an underlying issue that needs addressing. Another likely symptom is increased fuel consumption, as the PCM may not correctly calculate the air-fuel mixture when the throttle position data is inaccurate. Additionally, the vehicle may respond inconsistently when the accelerator pedal is pressed, causing unexpected delays in acceleration. Identifying these symptoms early allows for quicker troubleshooting, potentially preventing more significant damage to the engine or related components. The first step in troubleshooting the P0222 code is to ensure the vehicle is in the on mode, ready for diagnostic assessments. The HDS, or Honda Diagnostic System, is crucial at this stage. Technicians should clear the existing DTC to reset the system and retrieve fresh diagnostic information. Once the DTC is cleared, it's essential to check the current values from TP sensor B using the HDS. The expected value should be over the threshold of 0.3 volts. Documenting any readings below this will confirm whether the issue is persistent. If current conditions match the threshold, it's likely that the failure is duplicated, which signals that further investigations are necessary. However, if the result indicates intermittent failure, attention must shift towards inspecting the integrity of connections and terminals related to the TPS and the PCM, which could be influencing the low voltage reading. In the second step, using the HDS, technicians must check for any pending or confirmed DTCs. Specifically, examining whether DTC P0122, which indicates a similar low voltage condition for TP sensor A, appears concurrently with P0222, is vital. If both DTCs are confirmed, further investigation is warranted to identify common failures across both sensors. Understanding these relationships between DTCs can significantly streamline the troubleshooting process. Conversely, if only P0222 is present, the troubleshooting should shift to check specific wiring and connectors associated with sensor B. Establishing a clear path for diagnosis not only saves time, but enhances the accuracy of identifying the specific fault affecting the throttle position circuit. The third troubleshooting step involves conducting a short wire check on the THL2 line. First, ensure the vehicle is in the off-lock mode before jumping the SCS line with the HDS for safety and accurate diagnostics. After waiting more than 1 minute to register any settings, disconnect the connectors at the PCM connector B and the throttle body 6P connector. This disconnection is crucial to isolate the circuits and prevent erroneous readings. Technicians must then check for continuity between the specified test points, namely the throttle body 6P connector number 4 and body ground. If continuity is detected, this indicates a short in the THL2 wire that needs to be repaired. If continuity is not present, the wire likely remains intact, and the diagnosis can proceed towards examining authorized service information or substituting a known good PCM for further evaluation. In this step, technicians will focus on the VCC5 line, which is crucial for the throttle body's operation. Begin by ensuring the vehicle is in the off-lock mode. Then disconnect the throttle body 6P connector. Once this is done, switch the vehicle to the on mode to measure the voltage present at the throttle body connector number 5 in relation to body ground. A reading close to 5.0 volts is necessary for proper operation. This voltage indicates that the circuit supplying power to the throttle body is functioning correctly. If the measured voltage meets the specifications, replacing the throttle body may be the next step, as it suggests the sensor's operational deficiencies might be due to an internal fault. However, if the voltage is outside the expected range, the technician can then proceed to check for potential open wires in the system, which could lead to further troubleshooting. The fifth step entails checking for an open wire condition in the VCC5 line. Begin by returning the vehicle to the off-lock mode before performing a short on the SCS line with the HDS. This precaution helps maintain the system's integrity during testing. Disconnect the necessary PCM connector B and also ensure the throttle body 6P connector remains disconnected. Testing continuity between throttle body connector number 5 and PCM connector B number 5. 44 will help ascertain whether the VCC5 wire is intact. If continuity is confirmed, This indicates that the wires are functional, and diagnostic efforts should pivot towards either service information or replacing the PCM as potential solutions. However, if no continuity is found, it suggests an open circuit that will require repairs to restore proper electrical path and functionality within the system. Once repairs have been made concerning DTC P0222, a final verification is essential to confirm that the issues have been resolved. First, technicians should clear the DTC using the HDS and take the vehicle for a test drive under conditions that previously triggered the fault. During this test drive, it's important to observe and document any improvements in engine performance or response from the throttle, particularly paying attention to acceleration and power levels. Technicians should also ensure that the check engine light does not reappear during the test drive. If all parameters are functioning correctly and no further DTCs are present, it indicates successful repair of the efficiency being scrutinized. Conducting this verification step validates that the previous issues linked to the TP sensor B circuit low voltage have been effectively resolved. Integrating preventive maintenance into vehicle care can significantly decrease the likelihood of encountering DTC P0222 in the future. Regular inspections of electrical connectors and wiring associated with the throttle position sensors are essential to ensure a reliable electrical connection. Technicians should check for signs of wear, corrosion, or any damage that may impact performance. Keeping the throttle body clean and free from carbon buildup is also crucial, as it can affect the throttle plate operation and subsequently the TPS readings. Additionally, ensuring that all software updates are applied to the vehicle's PCM can enhance operational efficiency and bolster error detection capabilities. Consistent preventive measures help maintain the overall integrity of the engine management system, reducing downtime and increasing vehicle reliability. In conclusion, troubleshooting DTC P0222 involves a systematic approach that begins with diagnostic checks and progresses through targeted inspections and tests. Understanding the roles of the throttle position sensor and its associated circuits is vital for accurate diagnosis and repair. The emphasis on voltage readings at various test points helps technicians identify faults in the circuit effectively, as documented in the steps. It's also important to cross-reference for other DTCs that may influence the diagnosing condition. Regular preventive maintenance serves to enhance the reliability of the throttle position systems, ensuring smoother operation. Ultimately, being proactive in vehicle care can help address potential issues before they lead to larger concerns, keeping the Honda Pilot performing optimally and efficiently. Please like and subscribe to the channel. See you next time.